and this is our new video about thermodynamics.
Woo!
We still have little Jesus with the alien sombrero. We just took our AP Spanish test today, so all about the Spanish up in here.
Podemos hablar en español si
Todo
quieres.
tiempo. That's all I know. Okay, moving on.
That's all I know.
So thermodynamics is a lot about like ideal gas behavior. So when we're talking about ideal gases, there's a large amount of molecules moving at random. Collisions are elastic, which
These are
probably means something.
assumptions. These are assumptions.
Oh, these are assumptions about ideal gases. There's no intermolecular forces. No matter how cold we get, they won't condense. And then molecules of an ideal gas are extremely small and far apart. Yeah, I don't really know if that helps anything.
Yeah, so I feel like in this unit, it's just really important to know some of the equations. Better on the equation sheet,
Claro que sí.
Yeah.
Is that what you're
I was
saying?
going to say Claro. I don't know how to say that in English. Like,
Of course.
Of course.
Obviously.
I feel like Claro is a better word. That's just
I
me.
agree.
So,
also graphs. Very important.
graphs. PV diagrams. Very important.
Very important.
So,
Like, extremely important.
so
like,
equation,
it's going to be on the AP test.
KE equals 3 halves N.
Hope that they can see this.
Yeah, well, hopefully.
3 halves.
There's no N.
Oh.
I'll make that up. 3 halves KT.
What is K?
It's a constant.
What is T?
Temperature?
What is KE?
Kinetic energy.
Woo! Genius.
And so that's an important equation. Also, perv nerd.
Perv nerd.
PV equals nRT.
A good way to remember perv nerd is pervert.
Why'd you say perv nerd? That's what I do.
Oh, okay. Or you can be like, P equals pressure, V equals volume,
Mm-hmm.
N equals number of
Moles.
Moles. I was going to say
It
molecules.
might be like...
No, big N is number of molecules. Little n is number of moles.
Yeah.
I think. R is
a constant.
a constant, and T is temperature again. And so with this, we know that if pressure goes up, velocity will go down.
Well, I was gonna guess that there. An important fact about this equation is that often we need to know that PV is proportional to T, because these are essentially just constants in most equations. So therefore, it just makes it PV is equivalent to T, and that's important on graphing the pressure and volume and temperature, or
Definitely.
Just PV diagrams in general. This is just a really important fact, I feel like.
Yeah, I agree.
And about the only thing I've ever understood.
Yeah. And then the second law of thermodynamics is that heat always flows from object of high temperature to objects of low temperature. That's usually one question on the multiple choice. So you
can just make that up.
No, I didn't. I remember being on a multiple choice practice.
Okay. While we're going over laws of thermodynamics, 0 with law of thermodynamics.
Which is dumb.
Yeah,
Sorry.
well, it's a thing. It's basically saying if A. So.
Yeah.
Yeah, that's what I was gonna say with the note. Hold on.
Yeah, it's if A and B are in thermo-equilibrium.
If A. No. If it's.
Really
Okay, you
is.
can say your thing and then I'll say my thing.
Okay, I think
They're the same
they're the
thing.
same thing. If A and B are in thermo-equilibrium and B and C are in thermo-equilibrium, then A and C would be in thermo-equilibrium.
Mm-hmm. Yeah. So basically, if A equals B and B equals C, A equals C. Also, an important thing to note is that heat flows from, thermo flows from hot to cold.
Which I just said. You're not listening to me at all. That's fine. Also, some very important...
Hi, Emma.
Emma, hi!
I'm just gonna watch this and be like, no.
Okay, some important words to know. when talking about graphs of Pervnert is isobaric. You want to go over what that means?
That means constant pressure.
Yep. P is going to be constant in this case. Isothermal, which is pretty easy.
It's the same temperature.
Isometric.
Same volume.
Which is sometimes also called isovolumetric, which is even easier, and sometimes isochoric.
It's fine. It's just metric.
And then we know that if they're in a rigid container, that it's going to be isometric because it cannot expand or contract. And if it's a sealed container, that means we know that the moles remains constant, so the N in the equation. But N usually is just kind of whatever.
Yeah.
Okay. So when we're talking about average kinetic energy, it equals the same equation that Reagan just showed, but it also equals 1/2 mv squared. But it equals 1/2 average velocity squared. So K average equals 1/2 m average velocity squared, which makes a difference because you have to average the velocities. Yeah, it's just something I found.
I think something that we should go over is the stuff that I think that's called the PV diagram.
Yeah, I agree. That's very important. You want to do that? Because I always had troubles with that.
I did too.
And we struggled together. Yeah, bro.
So
then we'd ask Reshma. Hey, Reshma.
Hey, Reshma.
I hope she's watching.
She's probably not gonna watch this.
I tell her about this.
Oh, you did?
That's definitely not gonna be good.
No, we can make it just a graph. So, Jesus Christ, fine. So normally the graph, it goes in a way like this. I don't know, let's just make it go clockwise.
Clockwise is a good time.
And so essentially there are three important things
usually
about
this one's curved. Yeah, it does. Yeah, because that means it's isothermal.
That it's curved.
Yeah, because it's isothermal.
The curve shouldn't matter on this.
Yes, it does because it means
That's
it's isothermal.
different.
Curve is isothermal.
No,
because if it's not curved,
it's
then
just
isothermal.
isothermal in general.
No, if it's not curved, it's not isothermal. Because it's not direct. It's like a thingy. Dude, I'm right. I just know I'm right.
Mr. Holloway, if we end up showing you this, I hope you agree with me.
It's okay, he'll agree.
Oh, we're gonna show this?
Now we have to.
Okay.
This is really long. It's been 8 minutes.
Okay, anyway, so PV diagrams. There's a U that's important, a Q that's important, and W that's important. Right, so
Yes.
W...
I was going to go with U because we started with U.
I
so
knew what W was.
U is change in internal energy. Which change in internal energy equals 3/2 NR change in T or 3/2 change in PV.
Right.
Yeah, because you know that T is proportional to PV as we taught you before. Q is the heat added to the system.
Added, of course.
Yeah. If it's added, it's positive. If it's removed, it's negative. And then W is work done on the system. And if work is negative, then you lose internal energy. And if it's positive, you gain internal energy.
And also you find it by the integral. I don't really know how you found Q, so I don't know.
It's just kind of there.
Light.
Yeah, no, I don't really know
there's
either.
an equation that we use that it's on your equation sheet. I think it's change in U equals Q plus W.
And
so for example, if we were about to use that for this, to deduce the answer on our little chart, so we would know that work is weird. I remember this. So work is weird. Like, if you're going this way, the integral is going to be negative. So we're going to know that W is negative for
of
that.
the integral.
Yeah. And then...
And so you would just find the integral.
And we know that if W is negative, then Q has to be positive because they equal out to 0.
Why do we know that?
Because it equals out to 0, right? Question mark.
I mean, I feel like that's right, but no.
I don't know.
No, because Q is more
that
positive.
made no sense to me, ever.
Because Q is more positive. Because heat was added. Because we're just keeping a pressure and adding the volume, so heat has to be, like, overly...
Okay.
You just have to, like, deduce Q.
Okay. Q is a deduced thing.
Deduced. And Q is, like, really positive in this case, so U is positive. And then
that's about all that I feel like is good.
When we're going from B to C, for, like, here to here, U is going to be negative, and Q is negative, and work is 0. That, like, Q has to be negative, because work has to be 0. And then when... Yeah.
I'm kind of done talking about this diagram.
We have on our notes, or on my notes, that Victoria has to pee, and Reagan has to pee twice, and I only have to pee once. So this kind of shows you how much we learn in this class. Oh, if it's going clockwise, it's a heat engine. If it's going counterclockwise, it's a refrigerator.
Sexy.
I'm really good at winking. I'll have you know. Yeah, and that's kind of it, I think, with thermodynamics. I actually have more, but, like, entropy, who cares?
Yeah.
Okay, we're done.
Do we have to go?
Bye.